In the midst of this ambiguous project, such as revolutionizing the electric car industry and space exploration, Elon Musk has made a surprising announcement related to the historic Voyager probe mission. As a self-proclaimed space enthusiast, this latest revelation from Musk has caused astonishment in the scientific community. In his recent statement, Musk addressed the future of the twin Voyager probes and how long they will be able to continue on their incredible journey through deep space. In an exciting video, Musk unveiled an amazing space discovery, inviting everyone to embark on an unprecedented interstellar adventure. When Musk was 6 years old, NASA launched the two Voyager probes, and now, decades later, Musk feels a special connection to these iconic spacecraft as his own rockets take off from the same site in Florida from where Voyager was launched. It's amazing to think that after more than 50 years in space, Voyager is still operating. At the time of their launch, few would have imagined that these probes would continue their mission for so long, as their initial goal was only 4 years. However, they have exceeded all expectations, continually revealing new data about the universe. What many do not know is that the Voyager launch depended on a rare planetary alignment of Jupiter, Saturn, Uranus, and Neptune. This unique formation has not occurred since the time of Thomas Jefferson in the early 19th century. This alignment allowed the probes to receive gravitational boosts from each passing giant planet, as if an invisible string was pulling them forward, accelerating their journey. This brilliant strategy, devised by Gary Flandreau, an engineer at NASA's Jet Propulsion Laboratory, reduced the travel time from Earth to Neptune from 30 years to just 12 years. However, there was a catch: this realignment of planets occurs only once every 176 years. Aware of the unique opportunity it represented, NASA jumped at the chance, knowing that they couldn't pass it up. Taking advantage of this cosmic alignment, the agency decided to build not one but two identical spacecraft. The Voyager spacecraft, roughly the size of an old Volkswagen Beetle and equipped with a 69-kilobyte computer far less powerful than any modern device, set out on their missions. In fact, even a car key fob today has more memory than these pioneering spacecraft. Despite their technological limitations, the Voyagers had 8-track recorders to store data from their instruments. This data was transmitted to Earth via a transmitter with the equivalent power of a refrigerator bulb. To compensate for the weak signal, both spacecraft were equipped with 12-foot diameter dish antennas capable of sending and receiving data over long distances. Since their launch in 1977, the Voyager spacecraft have made a number of groundbreaking discoveries. Voyager 1, for example, holds the record as the farthest human-made object from Earth, being billions of kilometers in interstellar space. However, this feat is not easy, as the spacecraft faces extremely low temperatures and high levels of radiation. Since solar power is not feasible due to the great distance from the Sun, the Voyager spacecraft rely on thermoelectric generators (RTGs) for operation. Each spacecraft carries 3 RTGs that use plutonium-238 as a fuel source. As the isotope decays, it generates heat, which is converted to electrical energy. Initially, each Voyager produced around 470 watts and 30 volts of DC, but over time the power has decreased. Even so, this technology remains one of the few viable solutions for powering the spacecraft for decades, allowing them to continue their mission of exploration in the depths of space. In March 1979, after 546 days traveling through space, Voyager 1 finally arrived at Jupiter. Its sister spacecraft, Voyager 2, which launched a few weeks earlier, also reached the planet in July of the same year. These impressive space probes were designed to serve as stable platforms for their cameras, which used advanced filters to capture full-color images of the planets they encountered. Unlike the fast rotations of the planets, Voyager's motion in space was deliberately much slower, approximately 15 times slower than the movement of a clock's hands. This meticulously designed decision was made to ensure that the images were sharp and clear, minimizing the risk of blurred images that could compromise the mission. Voyager 1 began transmitting images of Jupiter while still months away from the gas giant, and the quality and detail of the images were exceptional. One surprising discovery was Jupiter's colorful moon Io, which defied all expectations. While the moons of the solar system were thought to be similar to our own, Voyager revealed an amazing diversity of lunar landscapes around Jupiter and Saturn that had not been anticipated. Voyager was also equipped with advanced instruments such as the low-energy charged particle system. From a distance of more than 1 million kilometers from Jupiter, the LCP detected unusual signals. suggesting that oxygen and sulfur ions were reaching the detector at levels never before observed, with an increase of 3 orders of magnitude. Although it was initially thought there might be an error, closer examination revealed that something extraordinary was occurring. In addition, Voyager's cameras discovered that Jupiter's moon Io harbored active volcanoes, solving a long-standing mystery. This moon, somewhat larger than Earth's moon, was confirmed as the most volcanically active body in the entire solar system. In fact, Io showed 10 times more volcanic activity than Earth, which completely challenged our previous notions about volcanism. Io's vibrant colors and strange ions detected by Voyager's instruments were related to materials ejected by the moon's intense volcanoes. Io's largest volcano, called Pelée, spewed plumes of material that reached 30 times the height of Mount Everest, scattering debris over an area the size of France. Voyager's cameras captured more than 33,000 images of Jupiter and its moons, revealing a wealth of new information. For example, scientists were surprised to discover that Jupiter had rings, an unexpected revelation. In addition, Europa, one of Jupiter's 53 known moons, showed a cracked icy crust more than 60 miles thick, adding a new level of mystery to this moon. As the probes continued their epic journey, they arrived at Saturn, where Voyager 1 traversed the planet's majestic rings and passed close to Titan. Voyager 2, meanwhile, headed towards Uranus and Neptune, making important discoveries in the process. It detected 10 new moons around Uranus and confirmed that Neptune, like Saturn, had its own ring system, thus expanding the list of ringed planets in our solar system. Voyager 2 came within 2,980 miles of Neptune 3 years later, where it measured the fastest wind ever recorded in the solar system, reaching 1,000 mph. It also confirmed that Triton, Neptune's largest moon, was one of the coldest places in the solar system, with surface temperatures dropping around 235 degrees C. Despite these extreme conditions, Triton showed ice volcanoes spewing nitrogen gas and particles up to 5 miles into the air, revealing another astonishing finding on the Voyager mission. Voyager 1 is famous for capturing one of the most iconic images of Earth, a story that would not be complete without the persistence of renowned astronomer Carl Sagan. When NASA was ready to turn off the probe's cameras after capturing images of Neptune and its moons, Sagan insisted that Voyager 1 take one last series of photos. His influence led to Voyager 1 directing its camera back to Earth on Valentine's Day 1990, capturing 60 final shots, including the legendary pale blue dot taken from a distance of 3.8 billion miles away. This image remains one of the most distant photographs of our planet, with Earth barely visible as a single pixel reflected in sunlight. Today, Voyager remains in contact with the control center. Although it moves 3 to 4 light seconds away each day, scientists use NASA's Deep Space Network, which has 3 tracking centers strategically located on Earth, to connect with the probes. Both spacecraft have crossed the heliopause, the boundary of our solar system, with Voyager 1 crossing it in August 2012 and Voyager 2 following more than 6 years later. However, true to their reputation for surprising their controllers, the Voyagers have recently sent back data that have left NASA puzzled. In particular, Voyager 1 has sent back signals that did not seem to match expectations about its altitude and orientation control system, leading scientists to wonder whether these data are authentic or just random noise. Despite its age, Voyager 1 remains one of NASA's most valuable spacecraft, demonstrating admirable performance for most of its mission.